Welcome to Echoes of My Imagination. My name is Tracy Lee. Sit back, relax. Let me tell you a story. Today's story is the continuation of how the world works. Let's get into it. Metal. I am born deep inside stars. Long before the earth existed, before oceans formed or stone cooled into continents, the elements that would become metal were created in places where matter was compressed to extreme density and heat. Inside massive stars, atoms collide under tremendous pressure. Hydrogen fuses into helium. Helium fuses into heavier elements. Layer by layer, the star builds new forms of matter within its core. Carbon forms, oxygen forms, silicon forms. Eventually, the process reaches iron. Iron cannot release energy through fusion the way lighter elements can. When too much iron gathers inside a star's core, the balance between gravity and nuclear energy fails. Gravity wins. The core collapses in an instant. What follows is one of the most violent events in the universe. The star explodes outward in a supernova, scattering enormous quantities of matter across space. In that explosion, elements heavier than iron are created as atomic nuclei collide with unimaginable energy. Gold, silver, nickel, copper. These metals form in the brief, violent heart of dying stars. The debris from those explosions spread through the galaxy. Over millions of years, gravity gathers clouds of gas and dust together again. New stars form. Planets begin to assemble from the remaining material. The Earth formed from that mixture. As the young planet grew, heat from constant impacts and radioactive decay melted much of its interior. Heavy elements began to sink toward the center under the pull of gravity. Iron and nickel flowed downward through molten rock and gathered to form the Earth's core. Lighter materials remained close to the surface, where they slowly cooled into solid crust. Even here, metals did not remain still. Deep underground, heat and pressure continue to move elements through rock. Hot water circulating through fractures dissolve metal atoms from surrounding minerals. When the water cools again, those metals crystallize into concentrated deposits. Over time, veins of copper, silver, and gold form within the stone. Some metals appear naturally in nearly pure form. Others remain locked inside ores that must be heated and separated before they can be used. Humans learned long ago that metal behaves differently from stone. When heated, many metals soften without breaking apart. Their atoms slide past one another while remaining connected through strong metallic bonds. This allows metal to bend, stretch, and take new shapes without shattering. When the metal cools, the structure becomes rigid again. This property allows tools, blades, and machines to be formed. Metals also conduct electricity easily. Inside them, electrons move freely through the lattice of atoms. When an electric field is applied, these electrons drift through the material, carrying current from one point to another. Because of this movement, copper wires carry electricity across entire cities. Metals also conduct heat efficiently. Vibrations within their atomic structures spread energy rapidly from hotter regions toward cooler ones. Even their surfaces reflect light strongly. Free electrons interact with incoming photons, sending much of that light back outward. This is why polished metals shine. Throughout history, humans have shaped metal to change their world. Iron tools cut forest and carve stone. Steel supports bridges and buildings. Aluminum forms the bodies of aircrafts that travel high above the ground. Copper carries electrical signals through the countless circuits. Yet even in these structures, metal remains what it always was: atoms arranged in ordered patterns, held together by shared electrons. From the violent death of ancient stars to the quiet structures built on Earth today, metals carry a long history of cosmic formation and planetary change. They are the heavy elements forged in extreme conditions and gathered together by gravity. I am matter shaped by the life and death of stars. I am metal. Electricity. I move through the smallest structures of matter. You cannot see me directly, but you can see the results of my motion everywhere. I flash across the sky during storms. I travel through metal wires to light cities at night. Inside living bodies, I carry signals from one cell to another. I begin with charge. Atoms contain particles with opposite electrical charges. Protons carry a positive charge and remain bound in the nucleus. Electrons carry a negative charge and move around the nucleus in regions of probability defined by quantum rules. Most of the time, these charges balance each other. Matter remains electrically neutral, but when electrons shift from one place to another, an imbalance forms. That imbalance creates an electrical field. An electric field exerts force on other charged particles nearby. If a free electron enters that field, it feels the pull immediately. It accelerates toward positive charge and away from negative charge. When many electrons begin moving together, the motion becomes organized. That motion is electricity. In metals, electrons can move relatively freely through the structure of atoms arranged in a crystal lattice. When a difference in electrical potential exists between 2 points, electrons drift through the material from one end to the other. Their movement is small and slow at the microscopic level, but the effect spreads quickly through the entire conductor. When that flow passes through a thin filament or a resistor, collisions between moving electrons and atoms transfer energy into heat and light. The filament glows. Lamps illuminate dark rooms. The same process powers motors, heaters, and electronic devices. Electricity also moves through the atmosphere. Inside storm clouds, rising currents of air carry tiny ice crystals and water droplets upward. Collisions between these particles transfer electrical charge. Over time, large regions of positive and negative charge separate within the cloud. The imbalance grows stronger until the electrical field becomes powerful enough to force a path through the air. A sudden discharge follows. Electrons surge across the gap between cloud and ground or between different parts of the cloud itself. The air heats rapidly, expanding with explosive force. You see the bright channel of lightning and hear the shock wave that follows as thunder. In that moment, an enormous amount of electrical energy releases in a fraction of a second. But electricity is not limited to storms or machines. It also flows quietly inside living organisms. Your nervous system depends on it. Cells called neurons maintain tiny electrical differences across their membranes. Sodium and potassium ions move through specialized channels, creating brief changes in voltage that travel along the length of the cell. These signals pass from neuron to neuron through chemical junctions called synapses. In this way, information moves through networks of billions of cells. Every movement you make begins with these electrical signals. Every sensation you feel, touch, sound, light, ultimately becomes patterns of electrical activity inside the brain. Electricity also controls muscles. When a nerve signal reaches a muscle fiber, It triggers a rapid release of calcium ions inside the cell. Protein filaments slide past one another, shortening the fiber and producing force. Your heart depends on this process. Electrical impulses move through specialized tissue that coordinates each contraction. With every beat, muscles tighten and relax in precise sequence, pushing blood through the body. Without these signals, the rhythm would stop. Even at the smallest scales, electricity shapes the structure of matter. Electrons are held near atomic nuclei by electric attraction. Chemical bonds form because charged particles interact with one another. Atoms join to create molecules. Molecules assemble into larger structures. From these interactions arise minerals, water, living cells, and the complex systems built from them. The stability of matter itself depends on electrical forces acting between particles. Though you often encounter me in wires and machines, my presence is far older than your technology. I existed long before the first storm crossed the early oceans of Earth. I am the motion of charge. I flow through clouds and copper, through nerves and muscle, through the smallest bonds that hold atoms together. Wherever charged particles move under the influence of electric fields, I am there. I am electricity. Magnetism. I move without being seen. You cannot touch me directly, yet you feel my influence whenever certain metals pull toward one another, or a compass needle turned toward the north. I arise from motion deep within matter. Inside every atom, electrons move continuously. They orbit the nucleus in regions defined by quantum rules, and they also spin on their own axes. Because electrons carry electric charge, their motion creates tiny magnetic fields. Most of the time, these fields cancel one another. In many materials, the electrons pair in ways that balance their magnetic effects. Their fields point in different directions and neutralize each other. The material shows no noticeable magnetism. But in certain elements, especially iron, cobalt, and nickel, something different happens. Within these materials, groups of atoms form regions where the magnetic fields of many electrons align in the same direction. These regions are called domains. Each one acts like a tiny magnet with its own north and south poles. In an ordinary piece of iron, the domains point in many directions. Their effects cancel each other, and the object behaves as if it has no magnetic field. When the domains begin to align, the material becomes magnetized. The fields reinforce one another and extend outward into the surrounding space. Invisible lines of magnetic force spread from one pole to the other. Objects made of magnetic metals feel those forces and move in response. This is the attraction you see when two magnets pull together. Magnetism also exists on a far larger scale. Deep inside the Earth, molten iron moves slowly within the outer core. The planet rotates as this conductive liquid flows. These motions generate powerful electrical currents, and these currents create a magnetic field that surrounds the planet. That field extends far into space. Invisible lines curve outward from the southern hemisphere, sweep around the Earth, and return near the northern hemisphere. A compass needle aligns with these lines, allowing travelers to determine direction even when landmarks disappear. This planetary magnetic field does more than guide navigation. High above the atmosphere, streams of charged particles flow outward from the sun. When these particles reach Earth, many are deflected by the magnetic field surrounding the planet. Instead of striking the atmosphere directly, they spiral along magnetic lines toward the polar regions. There, they collide with atoms in the upper atmosphere. Energy transfers during these collisions excite oxygen and nitrogen atoms. When the atoms return to lower energy states, they release light. Curtains of green, red, and violet glow across the night sky. These displays are known as the aurora. They reveal the presence of magnetic forces shaping the space around your planet. Magnetism and electricity are closely connected. Whenever electric charges move, magnetic fields appear around them. Likewise, changing magnetic fields can push electric charges into motion. This relationship allows generators to produce electricity and motors to convert electrical energy back into movement. Power plants rely on this interaction. Large coils of wire rotate within magnetic fields, forcing electrons to move through the metal. The resulting current travels along transmission lines and enter homes, machines, and cities. Even inside living organisms, magnetism plays subtle roles. Migratory birds navigate across the continents using the Earth's magnetic field. Specialized molecules in their eyes respond to magnetic orientation, allowing them to sense direction even during the long journeys across oceans and deserts. They move through the world guided by forces you cannot see. From the alignment of electrons inside atoms to the sweeping field that surrounds an entire planet, magnetism emerges wherever electrical charges move and interact. Invisible lines spread through space, shaping motion and guiding energy. You feel my pull when metal shifts in response to hidden forces. I am magnetism. Quanta. I move in steps. In the larger world, movement appears smooth. Water pours from a vessel in a steady stream. Heat spreads through iron and stone. Light fills a room the moment a lamp is switched on. Nothing appears to arrive in pieces. But the smooth surface of reality hides something smaller. Beneath the scale of dust, beneath cells, beneath the structure of atoms themselves, the world behaves differently. There, continuity ends. Energy does not flow freely through my domain. It does not divide endlessly into smaller and smaller portions. Instead, it travels in exact amounts that cannot be broken further. Each transfer happens in a single step. I am one of those steps. For most of human history, my presence went unnoticed. The effects were visible, but the cause remained hidden inside matter itself. One of the earliest clues appeared in the glow of heated metal. Place a piece of iron inside a furnace and watch carefully. At first, nothing seems to change. The metal darkens slightly as its temperature rises. Then, slowly, a faint red glow spreads across the surface. As the heat increases, the red deepens and brightens. Orange begins to appear. With greater heat, the glow turns yellow, then white. The pattern repeats every time. This glow is not fire. It is radiation released by vibrating atoms inside the metal. As temperature increases, the atoms move more violently and emit more energy into their surroundings. Early scientists attempted to describe this radiation using the physics they already understood. Their equations treated energy as something continuous, capable of taking any value. The mathematics produced a disturbing result. According to those equations, a hot object should release more and more energy as the wavelength of radiation becomes shorter. At extremely short wavelengths, the predicted energy becomes enormous. If the calculations were correct, every furnace would pour out an unlimited flood of invisible radiation. But this never happened. The glow of heated metal followed a precise and repeatable curve. The energy peaked at a certain wavelength and then declined. Something in the assumptions of classical physics had gone wrong. The mistake was subtle. Energy could not be released in arbitrary amounts. Inside the metal, vibrating atoms could only exchange energy with radiation in fixed packets. Each packet carried a specific amount of energy tied directly to the frequency of the radiation produced. My size is set by that rhythm. At the smallest scales, I reveal stranger behaviors still. A single particle can exist in multiple places at once, a superposition, until something in the environment disturbs it. The moment it interacts with air, light, or even a stray photon, that delicate multiple existence collapses into one definite outcome. That rapid entanglement with the surroundings is why the large world never shows its quantum face. Superposition and interference wash out almost instantly. Only the average classical behavior remains. That is why water looks continuous and heat feels smooth. Yet sometimes I slip through barriers that should be impossible. An electron facing a wall of energy it could never classically climb still has a small chance of appearing on the far side, as though it tunneled straight through. The thinner or lower the barrier, the greater the chance. Nuclei use this trick to decay. Microscopes use it to see atoms. I am Quanta, the indivisible grain at the heart of reality. Everything you see, everything that moves, everything that lives is built from countless numbers of me. From a distance, the steps blur together and the world appears smooth. Come close enough, and you meet me, the smallest, most stubborn piece of nature there is. Sound. I move through matter as motion itself. You hear me when air vibrates, when water carries waves, when solid materials transmit small movements from one point to another. Wherever particles move back and forth in organized patterns, I can exist. I begin with vibration. When an object moves rapidly in one direction and then returns again, it pushes against the material surrounding it. In air, this movement compresses nearby molecules together for a brief moment. As the object moves back, the molecules spread apart again. These alternating regions of compression and expansion form a traveling wave. Each group of molecules pushes against the next, passing the motion forward through the air. The molecules themselves move only small distances. What travels across the room is the energy of the vibration. This traveling disturbance is sound. When the wave reaches your ear, it enters a narrow canal and strikes a thin membrane called the eardrum. The pressure changes in the air cause the membrane to vibrate. Those vibrations pass through 3 tiny bones in the middle ear, which amplify the motion and deliver it to a fluid-filled structure called the cochlea. Inside the cochlea are thousands of delicate sensory cells. As waves move through the fluid, these cells bend in response to the motion. The bending opens microscopic channels that generate electrical signals. These signals travel along nerves to the brain, where they are interpreted as sound. In this way, simple vibrations in the air become voices, music, and the countless noises of the living world. Different vibrations produce different sounds. When waves repeat slowly, you hear low tones. Faster vibrations create higher pitches. The intensity of the vibration determines how loud the sound becomes. Complex sounds form when many frequencies combine. A human voice contains layers of vibration shaped by the lungs, throat, tongue, and lips. Musical instruments create distinctive patterns as strings, reeds, or columns of air vibrate in precise ways. Sound travels differently depending on the material carrying it. In air, waves move about 340 meters per second. In water, they move more than 4 times faster. In solid materials such as steel or stone, vibrations can travel even more quickly because the particles are packed closely together. Because sound requires matter to carry it, it cannot travel through empty space. Between the stars, where no air or water exists, silence dominates. Vibrations have nothing to move through. On Earth, however, sound fills the environment. Wind rustles through leaves. Water strikes rock in steady rhythms. Animals call across forests and oceans. Each vibration spreads outward through the surrounding air until its energy fades. Some animals rely on sound in ways humans rarely do. Bats release rapid pulses of high-frequency sound while flying through the night. These waves strike nearby objects and return as echoes. By measuring the time between each pulse and its echo, the bat forms a detailed picture of its surroundings. Dolphins use similar signals underwater, navigating dark ocean depths through echoes alone. In these moments, sound becomes a tool for seeing. Every vibration eventually fades. As waves spread outward, their energy disperses through the surrounding material. Molecules collide randomly again, and the organized motion disappears. The air becomes still. But while the vibration lasts, motion travels outward in expanding circles, carrying energy and information across the space between one object and another. Whenever matter moves and pushes against the particles around it, waves spread through the medium that surrounds it. I am that traveling motion. I am sound. And that's it for today. Thank you for joining me for Echoes of My Imagination. Don't forget to subscribe, share, follow, and like, and I'll catch you next time.